Alright, I know you're all excited. Hey, thank you for watching the video. This is my first one, so hope all this goes well this year. I'm looking forward to a great year. Let's do our little bit of trig review. In geometry days, or we'll be doing a lot of this in pre-calculus. Remember our term SOHCAHTOA. It's an acronym for what? The sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Okay? The tangent, the sine, the cosine of an angle come from these ratios, but they're only good for what? Right triangles. SOHCAHTOA only works for right triangles. We're going to use law of sines and law of cosines for triangles that aren't right triangles. Let's take a look at this triangle. Let's take angle A. Okay? Let's talk about sine. Let's get my pen going. Sine of angle A. Well, we remember what? So, the sine of an angle comes from what ratio? The opposite side over the hypotenuse. Okay, well, we know the hypotenuse is r. That's on the bottom. This is this over this. So that's going to equal over r. And what's opposite? Remember, opposite never touches the angle. It's across from it. Okay? So here's my, for angle A, hypotenuse, adjacent. There's my opposite. So that'll be y over r. The ratio y over r will give you some decimal. Okay? That's the same thing as if you plug in sine of A in your calculator, you get that same number. Okay? So if you put in sine of A was 30 degrees, you would get 0.5. Okay? Let's try cosine. Cosine of an angle comes from what? Let's try cosine of angle A again. Remember, that's the ka. Cosine, so ka. Cosine of an angle comes from the ratio of the adjacent side over the hypotenuse. What's our hypotenuse? R. So that's on the bottom. Okay? What's our adjacent side? Okay, here we're talking about angle A. Here's our hypotenuse. Is this thing way across here? Opposite A, is that adjacent? No, adjacent means next to. The adjacent side helps form that angle. Okay, so adjacent, this would be x over r is the cosine of angle A. If that was, again, 30 degrees, and you plugged in cosine of 30 degrees, you would get the square root of 3 over 2, whatever that number is, I forgot. Okay? Alright, so cosine, adjacent over hypotenuse. One more. What is it? Tangent. Okay? Let's do tangent of angle B. Tangent deals with TOA. The tangent of an angle, in this case angle B, comes from the ratio of the opposite over the adjacent. Notice tangent, we don't deal with the hypotenuse at all. There's no h. Okay? Here's angle B. What's opposite? Okay? Well, what side doesn't touch angle B at all? So what's across from angle B is this opposite side, x. So that's going to go on top. And what's adjacent? Well, remember, this is adjacent, but that's the hypotenuse. We know that's h. Here's adjacent because that helps, the adjacent side helps make that angle we're talking about, in this case B. So x over y. Okay? The tangent of B, if it's 60 degrees, When you plug in tangent of 60, you get some number. That's the same number that you get when you get x over y. Okay? So, let's take this situation. Two things I'm going to talk about here. One, here's an airplane at a certain altitude, and here's some person on the ground. When he looks up, that's called an angle of elevation. Okay? That's when this person, he or she's looking straight out, and then from that line of sight up, from here up is your angle of elevation. By the same token, or kind of reversing, here's this pilot up here. His line of sight is out here. When he looks down, that's an angle of depression. Okay, so that would be also 35 degrees. Okay, this would be angle of depression, and this is angle of elevation. Okay, in any event, let's use SOHCAHTOA to solve some problems. Okay, let's say this plane is 5 miles high, so roughly 25 to 30,000 feet in. Okay, how far is this person standing away? So we want to know, where's our x? We said, how far is this person standing? Well, let's say, how far is this distance horizontally from the plane? So we want to find out this, the horizontal distance, not this distance, okay? So we assume this is a right triangle, okay? What am I dealing with? Are we dealing with the hypotenuse at all? We didn't ask that. We're given this altitude, and we want to know this distance from this. So we're dealing with this angle here. Okay. So I've got an angle. I've got what? The opposite and adjacent. What are we going to use? Opposite and adjacent. There's no hypotenuse. It's got to be tangent. So tangent of 35 is going to equal what? 5 opposite over adjacent. Opposite over adjacent. Okay? That's going to be 5 over x. So I'm going to replace this with 5 over x. Okay? Now, guess what? This is going to be easy. I've got my x on the bottom. If I multiply both sides by x, this cancels out. Or, better yet, let's do this. I'll undo that. Let's make a cross product. Okay? Tangent, 35 degrees over 1. So guess what? 5 equals x times tangent of 35 degrees. And now all we have to do is what to get x by itself? This is multiplication. We're going to undo. We'll divide everything by tangent of 35. Tangent of 35. And that's what we'll have. X equals 5 over, divided by, in your calculator, tangent of 35 degrees. And that will tell us what x is. Okay? Let's do a couple more. Now I want to know, let's say this is 6 miles. And we want to know that distance, the line of sight from the pilot to the person on the ground. And we know the person is horizontally 6 miles from that plane. Okay? What are we dealing with? We've got an angle, and we've got what? The hypotenuse, so it's got to be SO or CA, but we've got what? The adjacent side, not the opposite. So we're going to use what? Cosine. So cosine of 35 degrees, what? Equals adjacent over hypotenuse. Remember, that's CA. Adjacent is 6 over x. Again, we'll do a cross product. 6 times 1 is 6. Let me go change colors here. And that's going to equal x times cosine 35. Okay? So how do we solve for x again? We want to get rid of the cosine, so we undo it with division. If it's up top, we divide on the bottom. Okay? Divide by cosine of 35. And over here I do the same thing. Divide by cosine of 35 degrees. And this cancels out. X equals 6 over cosine of 35 degrees. Okay? So we've done tangent, cosine, and let's try a sine problem now. Okay? Let's say I know this right here. This is 6 miles again. And I want to know the plane's altitude. Okay? We've got an angle right here. What are the players in the situation? We've got an angle. We've got the opposite side, and we've got the hypotenuse. That's what's given. We're not using the adjacent side. Notice the adjacent, there's no information given, so what? What do we know? We know we can't use tangent or cosine because they both have A in the acronym. Okay? So I've got to use what? Sine. Sine is the only thing I use. This is opposite, and that's my hypotenuse. So that's sine. Remember, that's the so. Sine is opposite over hypotenuse. That's x. Sine of 35 degrees is going to equal opposite over hypotenuse, x over 6. This is easier math here. Again, if we do a cross product, x equals 6 sine of 35 degrees. Okay? So when your variable's up top, it's much easier. It's easier math. Okay? It's one less step. Okay? So those are the 3 ways we can solve problems. Now, just to follow up, this for right triangles. You can do angles of depression, angles of elevation. But one thing, if you know 35 and you know 90, these two sides have to add up to 90, so that would be what? 55. So you can use different angles if you want to solve for whatever sides. You can use cosine of this angle here might give you sine of this angle, but we'll get more into that, okay? That's all I've got. You should be ready to go tomorrow to work some of these problems in your spiral. So these notes should be on the first page that we're going to take notes on. We have 4 pages for table of contents, and then we start our notes to be page 1. Okay? All this should kind of be on here, and you can stop and start, and hopefully this works out. Okay? All right. That is it. Take 1.